Earth spins around itself at a staggering speed. At the equator, you and I and everything around us are moving at nearly 1,670 kilometers per hour without feeling a thing. The reason we don't notice is simple. We're moving at exactly the same speed as everything else around us. But imagine for a moment that this rotation suddenly stopped. Not gradually over millions of years, the way it actually does due to tidal friction, a complete stop in under a second. Today, we're not just going to imagine the aftermath, we're going to walk through it, second by second, minute by minute, until an entire planet is transformed. And along the way, you'll see that some of this story is already happening, quietly, right now. Before the countdown begins, let's actually understand the number we're dealing with. 1,670 kilometers per hour isn't just fast, it's roughly 1.5 times the speed of sound. It's more than double the cruising speed of a commercial airplane. It's the kind of speed that, if you were suddenly launched at it horizontally, would be instantly and completely unsurvivable. And here's the twist. That speed isn't the same everywhere on Earth. It's fastest at the equator, where the planet's circumference is largest, and it drops to almost zero right at the poles, where you're essentially just spinning in place like the center of a record. That difference in speed by latitude is exactly why the disaster we're about to describe wouldn't hit every part of the world equally. Some regions would be obliterated in the first second, while others would barely feel a nudge. Here we need to understand a fundamental physics concept called momentum. Any moving object wants to keep moving at the same speed and direction unless something forces it to stop. The problem is, if Earth suddenly stopped, the atmosphere, the oceans, and you and I wouldn't stop at the exact same instant, the same way passengers keep moving forward when a car slams on its brakes. At the equator, anything not directly and powerfully anchored to Earth's bedrock, meaning every building, every person, all the water, all the air, would keep moving at roughly 1,670 kilometers per hour, while the surface beneath it had already stopped. The result? Everything on the surface would go flying horizontally at speeds dozens of times greater than the most powerful hurricane ever recorded, at the same instant in nearly every location on the planet. The entire atmosphere would behave like water in a cup that suddenly stops spinning. It would keep moving with terrifying inertia. The resulting winds from Earth's sudden stop could reach hundreds of kilometers per hour at the equator, and in some regions could even approach the speed of sound. These winds alone would be enough to wipe out any structure not engineered to withstand disasters of this scale, and would carry away anything not firmly anchored to the ground: cars, trees, even layers of topsoil. Regions closer to the poles would be relatively less affected, since their rotational speed was already close to zero even before the stop. Here's something that makes this whole scenario feel less like pure fiction and more like an extreme version of something scientists track every single day. Earth's rotation isn't perfectly constant. It's actually slowing down, very gradually, due to tidal friction with the moon. Scientists measure this so precisely that international timekeepers occasionally have to add a leap second to global clocks just to keep atomic time in sync with Earth's actual rotation. That's how sensitive our timekeeping systems are to Earth's spin. A change of a fraction of a second, spread out over years, is enough to require a global correction. Now scale that up to a complete, instantaneous stop, and you start to understand why the scenario we're describing today isn't just dramatic for effect. It's dramatic because of how enormous the numbers involved actually are, even when the real, gradual version is almost imperceptibly small. The oceans would be subject to the same momentum principle, just on a far larger scale. The immense volume of water that had been moving with Earth's rotation would keep surging forward, forming megawaves unlike any tsunami ever recorded. Waves potentially capable of flooding entire continents from the inside, not just their coastlines. Equatorial regions, which had been moving at the highest speeds before the stop, would experience the most violent waves. Continents near the equator, parts of Africa, South America, and South Asia, could face water surges of heights and speeds unprecedented in all of recorded human history. Here's a subtler change that most people would never think of, but that would reshape weather forever. Right now, the Coriolis effect, a consequence of Earth's rotation, is the reason hurricanes spin counterclockwise in the northern hemisphere and clockwise in the southern hemisphere. It's the reason large-scale wind and ocean current patterns curve the way they do across the entire planet. Without rotation, the Coriolis effect simply vanishes. Storm systems would no longer spin in predictable rotating patterns. They'd behave completely differently, and meteorologists would essentially have to relearn how weather works from scratch. Combined with the immediate destruction from the initial winds and waves, the entire logic behind how storms form and move would be rewritten overnight. Once the initial catastrophic storm relatively settles down, or rather, once it finishes destroying everything in its path, we face an entirely different problem. Without rotation, Earth would keep orbiting the Sun as usual, but there would be no rapid day-night cycle the way we're used to. Instead of a 24-hour day, we'd have a single day lasting roughly a full year. Half the year in continuous daylight, half in continuous darkness, depending on exactly where you are on the planet. Regions on the daylight side at the moment of the stop would face months of relentless, uninterrupted sun exposure with no nighttime cooling at all. Other regions would plunge into months of unbroken, bitter polar cold with zero sunlight whatsoever. Here's a detail almost nobody considers. Satellites in orbit don't actually depend on Earth's rotation to keep moving. They're governed by their own orbital mechanics around the planet's mass, which barely changes in an instant. So satellites would largely keep orbiting normally. But the ground stations tracking them, communicating with them, and receiving their data, those just got wiped off the map by hurricane-force winds and megawaves. GPS, global communications, weather forecasting, internet backbones routed through satellite relays, all of it would be thrown into chaos. Not because the satellites failed, but because the civilization on the ground meant to operate them didn't survive the first hour intact. It's a strange twist. The technology safest from the disaster is also the technology that becomes instantly useless without us. Here we enter a far deeper, invisible danger. Earth's magnetic field, which shields us from cosmic radiation and dangerous solar wind particles, isn't just some incidental byproduct. It's primarily generated by the movement of molten iron in Earth's outer core, movement that's partially tied to Earth's own rotation. A sudden stop wouldn't instantly shut down the magnetic field. The core would keep moving for a while due to its own inertia. But over the medium term, a weakened or disrupted rotational pattern could begin to affect the field's strength and stability. If the field weakens significantly, Earth would become far more exposed to harmful cosmic radiation, and we might even see auroras, normally confined near the poles, appearing much closer to the equator due to the magnetic field's disruption. Months into this hypothetical scenario, Earth's climate map would have transformed radically. The hemisphere that had been on the daylight side at the moment of the stop would have endured months of continuous heat, rendering vast regions completely uninhabitable, while the other hemisphere would be almost entirely frozen after months of continuous darkness. Plant life, which depends on a regular daily cycle of light and dark, would be catastrophically affected. Most plants simply aren't biologically built to handle 6 straight months of constant light or constant darkness. The entire food chain, from the smallest microorganisms to the largest animals, would face unprecedented pressure in an extremely short period of time. The good news: Earth's rotation stopping completely and suddenly is physically impossible. Earth carries an enormous amount of angular momentum, and there's no known force in our solar system capable of stopping it all at once without utterly destroying the planet in the process, rather than simply halting it. The reality is that Earth's rotation is actually slowing down, but at an incredibly gradual pace, fractions of a second every century, the same tiny drift that occasionally forces global timekeepers to add a leap second. That means, calculated precisely, days are gradually lengthening over millions of years, not stopping all at once. But the extreme scenario we walked through today reveals something important. Everything we depend on in our daily lives, the gravity that keeps us standing, our mild climate, the predictable spin of every hurricane, even the very concept of a day, is the result of an extremely delicate balance we shouldn't take for granted. If you enjoyed this video, subscribe.